Hey everyone, welcome to another deep dive.
Excited to be here.
Today we're diving into the world of Polygon's AggLayer.
Yeah, it's a fascinating development.
It promises to connect different blockchains seamlessly.
Like building bridges between different blockchain ecosystems.
We've got some dense technical documents and blog posts to unpack.
We'll break it all down into plain English.
So buckle up. This is going to be a wild ride.
Absolutely.
Imagine a universe where blockchains can easily communicate with each other, like cities bustling with interconnected activity.
That's the grand vision behind AggLayer.
It aims to make this a reality, and we're here to figure out how.
And why it matters.
Exactly. We're talking faster, cheaper transactions, a whole new universe for dApps, and a truly interconnected Web3.
This is the future we're talking about. And what's fascinating is that AggLayer isn't just some far-off dream. It's already making waves.
Oh yeah, I've been seeing a lot of buzz around it.
The document you shared, AggLayer by Polygon, gets into the nitty-gritty, but let's pull out the highlights.
Yeah, let's simplify it for everyone.
They're calling it an in-development interoperability protocol.
Okay, so what does that mean in plain English?
Basically, it's aiming to be a universal translator for blockchains.
Like a universal plug adapter for crypto. So no more needing a dozen different wallets to navigate the blockchain world.
Exactly. Right now, if a developer wants to build an application that works across multiple chains, say one that lets you move assets seamlessly from Ethereum to Polygon to, well, you name it.
Yeah, I've been there. It's a nightmare.
It's a real headache. It's like trying to send a postcard, where every city speaks a completely different language. You need a different translator, or in this case, a different bridge for each one.
And bridges, well, they're not exactly known for being secure, are they? I mean, we've seen what can happen when those crumble millions of dollars lost in hacks and exploits.
Exactly, and that's where AggLayer's approach really stands out. It aims to solve this problem not just by creating another bridge, but by establishing a common language that all these chains can understand.
So, like a universal language for blockchains. That's ambitious.
It is, and the foundation of that language, ZK proofs.
Ah, yes, ZK proofs, those magical mathematical enigmas.
They're often seen as complex, but the concept is actually quite simple.
Okay, I'm listening. Explain it like I'm 5.
Imagine you have a winning lottery ticket. You want to prove to your friend that you won, but you don't want to reveal the actual numbers on the ticket just yet.
Okay, I think I'm following.
ZK proofs are a way to show your friend you have the winning ticket without actually showing them the ticket itself.
Okay, that's actually a really good analogy. So how does this lottery ticket magic translate to the blockchain world?
It all comes down to verifying information without revealing the underlying data.
Okay, that makes sense.
With AggLayer, instead of each chain needing to know all the nitty-gritty details of a transaction happening on another chain, they can simply verify the proof that the transaction is valid.
So it's like sending a sealed diplomatic pouch instead of a whole caravan of documents.
Exactly.
Yeah.
More secure, less overhead.
And the really exciting part is this isn't just theoretical. AggLayer is already making connections in the real world, right?
That's right. The alpha version is live with a growing list of chains plugging in. And while the initial focus is on chains built using Polygon CDK, their ZK-powered Layer 2 toolkit, the long-term vision is much broader. Polygon wants to extend AggLayer's reach to encompass a wide range of blockchain architectures.
Creating a truly interconnected web of chains.
Exactly. A true internet of blockchains.
Okay, interconnected, secure. I'm practically hearing blockchain angels singing. But how does this symphony of chains actually play out in the real world? Let's get into the nitty-gritty of how AggLayer works. Our trusty document, AggLayer by Polygon, breaks it down into a few key components. What's first on our tech treasure map?
You always need a solid foundation, right? And for AggLayer, that foundation is Polygon CDK.
CDK.
This toolkit provides the building blocks for creating those ZK-powered Layer 2 chains we talked about, and it ensures that each step in a transaction, each change in the blockchain state, is backed by those, like, ironclad ZK proof.
Got it. So CDK is like the bedrock, making sure everything built on top of it is rock solid. And then we have this intriguing unified bridge. It sounds like something out of a science fiction novel where starships from different galaxies can dock and share their cargo.
I love that image. And in a way, it's not that far off. Remember how we talked about the headache of needing a separate bridge for each pair of blockchains you want to connect?
Oh yeah, like trying to assemble a massive puzzle where each piece only fits with one other piece.
Exactly. AggLayer throws out that puzzle and gives you a single, elegant solution, the unified bridge. It acts as a central hub, a universal docking station, if you will, for all the different chains connected to the AggLayer network.
Okay, starting to get that unified feeling now. But what really caught my eye was this concept of unified liquidity. It sounds like something you'd find in a mystical energy vortex, not the blockchain world.
I assure you, no mystical vortexes here, just some clever engineering. Think about it this way. With traditional bridges, you often have separate pools of liquidity for each one. It's like having a bunch of small, isolated ponds instead of one big lake.
And I'm guessing that's not so great for the flow of, well, value.
You got it. Fragmentation leads to inefficiency. Swapping assets becomes more expensive, and the market can't reach its full potential. Unified liquidity, as the name suggests, aims to solve this by creating a shared pool of liquidity across all those connected chains.
So AggLayer is basically merging all those little ponds into a giant crypto lake, making it easier and cheaper to move assets around. Like the way this is flowing. But we can't forget about the brains of the operation, right? The document mentions the AggLayer service. Fill us in on what makes this service so special.
It's all about verification and trust. Remember those ZK proofs that each CDK chain generates for every transaction?
Yeah.
Well, the AggLayer service acts like a diligent inspector, carefully examining each proof before it's sent off to the Ethereum mainnet for final settlement.
So it's adding an extra layer of security, making sure everything is on the up and up before it hits the big leagues.
Precisely. And they've got a couple of different implementations for this service, one written in Go, another in Rust. A bit of a technical detail, but it speaks to the care and attention to detail they're putting into building this thing.
I appreciate a good tech flex, but let's bring it back down to earth for a second. Say I want to send some tokens from Ethereum's layer 1 to a shiny new app running on a Polygon CDK-powered layer 2.
Yeah.
How does this whole AggLayer process work in action? I need a play-by-play.
Okay, let's walk through it. You go to your favorite wallet and initiate the transfer. What happens behind the scenes is that the unified bridge contract on Ethereum springs to life. It takes your request and creates a record of it in something called an exit tree.
Exit tree. Sounds a bit like something out of Tolkien, but I'm intrigued. Break it down for me.
Think of it like a secure ledger, a kind of magical tree where each leaf represents a transaction leaving Ethereum.
Okay.
The structure of this tree, combined with some clever cryptography, allows for efficient verification of transactions.
Okay, so my transaction is now a leaf on this magical exit tree. What happens next?
This is where the AggLayer service and the ZK proofs take center stage. The service receives your transaction details from that exit tree and verifies that everything checks out, that you have the tokens you're trying to send, that the transaction is properly formatted, and so on.
Making sure I haven't cooked the books or anything.
Exactly. And remember, the beauty of ZK proofs is that it can do all this without revealing the actual details of your transaction to the entire network. Privacy preserved.
I'm starting to see why they call this thing Layer 0. It's like the invisible infrastructure that makes all the other layers work together seamlessly.
It's a great way to think about it. Once that AggLayer service is satisfied, it generates a ZK proof confirming the validity of your transaction. This proof is then sent over to the receiving chain, in this case, your Polygon CDK Layer 2.
So it's like sending a certified, tamper-proof seal of approval along with the transaction.
Exactly. And because that Layer 2 trusts the AggLayer service and the underlying ZK proofs, it can instantly unlock your tokens on that side. Boom, you're ready to interact with your dApp. And the process works in reverse, too, for when you want to move those assets back to Ethereum.
So we've got this secure, efficient token pipeline flowing between chains. But I can't help but wonder, what kind of horsepower is driving this whole operation? The document mentions this Polygon Type 1 prover and its role in generating those ZK proofs for Ethereum blocks. Is that the engine under the hood here?
Yeah, you could say that. It's a pretty impressive piece of engineering. Remember how we were talking about ZK proofs being like a universal language?
Yeah.
Well, it turns out that even within that language, there are the different dialects, you know?
Oh, interesting.
The way you generate a ZK proof for Ethereum with its EVM architecture, it's different from how you might do it for another blockchain with a different design.
So it's like you have one universal translator, but you need different language packs to communicate with different blockchains.
Exactly. The Type 1 prover is specifically designed to speak Ethereum's language fluently. It ensures those ZK proofs are compatible with the EVM, which is really crucial for AggLayer to work its magic within the Ethereum ecosystem.
Got it. Okay, so why go through the trouble of creating this specialized prover? Couldn't they just use any old ZK proving system?
Well, they could, but it wouldn't be nearly as efficient, and it definitely wouldn't be as cost-effective. Generating ZK proofs, especially for something as complex as the EVM, it can be really computationally intensive.
Oh, I bet.
And that means higher costs and slower transaction times.
That makes sense.
So the Type 1 prover is kind of like that high performance engine. It's keeping the whole AgLayer machine running smoothly and affordably.
Okay, I like that analogy. So walk me through this then. How does it actually achieve that efficiency?
Well, they've designed it with this really cool modular approach. So instead of it being one giant block of code, it's broken down into these specialized modules, each one optimized for a very specific task. You've got modules for things like arithmetic operations, for hashing, for handling logic functions. They all work together in perfect harmony.
So it's like a well-oiled pit crew, each member handling their specific task with lightning speed to get those ZK proofs out the door.
Exactly. And it's this efficiency that leads to some pretty impressive cost savings. In fact, the document mentions that the Type 1 prover can actually reduce the cost of generating those Ethereum proofs by up to 90% compared to some existing methods, which is huge.
Wow, 90%. That's incredible. Cheaper and faster transactions. Who wouldn't want that?
Mhm.
But let's zoom out for a moment. We've explored the technical intricacies of AgLayer, but where does it all fit within the grand scheme of Polygon's vision? We've got these blog posts you shared, Polygon protocols and reorgs demystified, that really hint at the bigger picture here.
You're right. It's not just about building one amazing bridge. It's about connecting that entire ecosystem. Polygon has always been about creating this multi-chain future, and AgLayer is a really key piece of that puzzle.
So AgLayer is like the bridge between bridges. It's not just connecting different blockchains, but it's connecting Polygon's own suite of scaling solutions as well.
Exactly. I mean, think about it. You've got Polygon POS transitioning to a ZK EVM Validium. It's going to offer just incredible scalability, but it's going to require very robust monitoring to keep everything running smoothly. And then there's Polygon ZK EVM, which is aiming for that coveted Type 2 status, which promises even greater security and compatibility with the Ethereum ecosystem. Not to mention we've got Polygon CDK, which is empowering developers to build their own custom ZK-powered chains tailored to their specific needs.
It sounds like Polygon is building this interconnected web of chains, a kind of blockchain internet, where data and value can flow seamlessly between these different worlds.
That's a great way to put it. And as Polygon scales, connecting more chains, handling more transactions, the importance of security and reliability only grows. And that's where the reorg's demystified blog post comes in. It highlights the critical role of network monitoring and observability in all of this.
Yeah, that post got me thinking about the challenges of maintaining a healthy network at such a massive scale. They talk about these reorgs, which honestly sound a bit like something out of a blockchain horror movie.
Right. They do sound a little scary, but in reality, they're just a normal part of how blockchains work. Essentially, a reorg happens when there's a temporary fork in the blockchain, and the network has to decide which branch is the true chain.
Okay, that makes sense.
Yeah.
So Polygon has this whole sensor network in place to monitor for these reorgs and ensure that any potential issues are, addressed quickly.
Yeah, exactly. It's all about being proactive, identifying those potential problems before they become major headaches. And that focus on security and stability is just absolutely crucial as Polygon aims to onboard even more users and applications.
It's an exciting time to be following this space, and I, for one, can't wait to see what innovative applications emerge as AgLayer becomes the backbone of this interconnected blockchain world.
Me too. It's really going to be game-changing.
Well, on that note, we'll wrap up this deep dive into Polygon's AgLayer. As always, be sure to check out the show notes for links to all the documents and blog posts we explored today.
Absolutely. Thanks for having me.
Thanks for joining us, and we'll catch you in the next deep dive.